So chemical equilibrium, guys. So we have seen so many things. Now today we are going to start with the homogeneous equilibrium and heterogeneous equilibrium, right? So what is the meaning of this homogeneous? Homo means what? What do you say? What will be the meaning of this homogeneous? See, guys, if similar condition will be there, if similar condition will be there, it will be what? If similar condition will be there, then it is homogeneous. Homo, right? If you will be going to see in a case of man, right? Same. Yes, Kanishka has written same. You might be have heard about in biology as well. Man and man. It will be what? Homo. Female and female. It will be what? Homo. But man and female, that will be what? Hetero. Right? So homogeneous equilibrium. So what will be in the homogeneous equilibrium? An equilibrium condition for a reaction with the reactant and product are in the same state. Same state means what? If either it will be in solid state and the product will be also in solid state. If it is in liquid state and the product is also in liquid state, then it will be in same phase or same state. Is it okay? So what is homogeneous equilibrium, everyone? Any doubt? No? Okay, fine. In the last class, we have seen about the chemical reactions rate, right, and equilibrium as well. If forward reaction is equal to the backward reaction, then we will be calling this what? It is a condition of what? Equilibrium? Yes or no, guys? And we have also find the value of Kc. Let's suppose we are having an equation AA, BB, right? Gives what? CC and DD. Then what we can write for this Kc? What will be the value of this Kc? See, guys, what we can write for this? C. The product of concentration of the product, that is C, raised to the power stoichiometric coefficient of this C, that is what? Concentration of D to the power what? Stoichiometric coefficient of this D upon coefficient of A to the power A and coefficient of power B to the power small b. Is it okay? Is it okay, guys? Any problem? And if I will be going to ask you what is this QC, so QC is also same. What is this QC? If I will be going to ask you QC, QC will be also same. C. Concentration of C to the power C and concentration of D to the power D upon concentration of A to the power A, that is small a, and concentration of capital B to the power small e. This will be QC. But is QC and Kc will be equal? See, if Kc is equal to QC, then it is a case of what? Equilibrium. QC can be, see guys, QC can be equal to Kc. QC cannot be equal to Kc as well. Right? Is it okay? QC means what? At any point of time, what will be the at any point of time, what will be the value of this? We will be finding QC. Is it okay? But at Kc, it means what? See, if reactions are happening here, right? Let's suppose water is there. If I am saying about the Kc, let's suppose this is filled up to here, right? And after reaction, if we are having, we have attained the equilibrium condition. We have attained the equilibrium condition, right? So it is what we are going to find the Kc only, right? But in QC, see here, this is what? Reactant. This is what? Reactant. And this is what? Product. This is what? Product. It means what? Reactant is equal to the concentration of reactant is equal to the concentration of product. In QC also, what will happen? See, this is what? Let's suppose water is there. And we have got this much of water only, this much of the product only, right? This is what? Reactant and this is what? Product. So we will be finding what? We will be finding what? QC. We will be finding what? QC. And the QC will be what? This upon this. Is it okay? So QC will be telling you that how much the reaction should have to do so that we will be getting the equilibrium condition. Is it okay? Is it fine for everyone? And let's suppose if I am asking, if see guys, if this reaction has not been in equilibrium condition and this much product you have got only, so the reaction will shift towards where? Backward or forward? If we have to attain this position, and we have got only this product, only this much amount of product we have got. So reaction should be forward. If let's suppose we have got product, lots of products are there, and we haven't attended the reactants, so the reactions will be moving backward. In equilibrium condition, what is happening? Yes, very good, Vishnupriya. So in case of forward reactions, if lesser amount of product has been formed than the reactant, then the reactant will be shifting towards the what? Then the reactant will be shifting towards the forward. And if the product is more and reactant is less, then the reaction will be shifting towards the left, that you can say the reactant side. And then the reaction will be called as backward reaction. Is it okay? No. Come to the point. So you might have seen these things in your earlier classes about elements, compound, they are pure substances, mixtures, homogeneous, heterogeneous. These things you might have seen in your earlier classes. Okay, guys. Now, what are the examples of this homogeneous equilibria or homogeneous equilibria? See, guys, we are having what? N2. N2, that is what? Gas, plus 3s2. 3s2. This is what? Gas. Giving what? Giving 2NH3. 2NH3. This is what? Gas. Can it be a homogeneous mixture or heterogeneous mixture? What do you say? This will be what? Homogeneous or heterogeneous? What do you say? Anybody will be telling me on this or not? Please tell me, guys. Homo. Why homo? Because see here, what are the phases here? Gaseous phase is there. Gaseous phase is there. Here also we are getting what? Gaseous only. So this reaction will be what? Homogeneous equilibrium. Is it okay? If this is happening, then it is a case of what? Homogeneous mixture. Is it okay? Now, second case is what? We are having what? CS3. CS3COO C2H5. Right? Plus H2O. See, guys. This is in aqueous. This is in what? Aqueous. And this is in liquid, right? Again, we are getting what? CH3COOH. We are getting what? We are getting what? CH3 CH3COOH plus C2H5 plus C2H5OH plus C2H5OH. Then what do you say? What will be this? Whether it will be homogeneous or heterogeneous? See, guys, we are having what? Aqueous, liquid, aqueous. These all are in what? Same phase only, right? So it will be what? It will be only, that is homogeneous, right? Here, Fe3 aqueous, SCN aqueous, giving what? FeSCN, that is aqueous. So these all are what? These all are homogeneous equilibria. Is it okay? Any problem till here? Fe3, see here, guys, Fe3 plus what? SCN, giving what? Giving what? FeSCN2, and they all are in what? Same phase, that is what? Aqueous and aqueous. Is it okay? Any problem till here? No problem. See, guys. So let's suppose here their water is there. Yes, Vishnupriya. If I have to change this in aqueous, then will it be in a homogeneous or not? Then it will be in homogeneous. Okay. Now come to the next point. So guys, you can So you can have a note of these things. That is what, when the state of equilibrium in a system has component in more than one phase, it is termed as heterogeneous. Is it okay? What will be the heterogeneous? One will be in gas, other will be in solid. One will be in solid, other will be in liquid. One will be in what? Liquid, and other will be in gas. Then it will be called as what? Heterogeneous mixture or heterogeneous equilibrium. Is it okay? Any problem till here? See, guys, if we take a container with ice and water at a temperature that is allowing the existence of both the phase simultaneously, both the ice and water are present in a state of equilibrium. When this happens, can anyone tell me? When this happens? Guys, you might have heard about that ice at 0 degrees Celsius, it starts melting. Yes, everyone, is it okay with this? What happens with ice? Ice at 0 degrees Celsius, it starts melting. And at the same temperature, water will be converting into what? Ice. So one is what? Ice is what? In solid state. And water is what? In liquid state. So both can be exist in the same, see, we have seen these things. They will be existing in the same condition. If that will be existing in the same condition, then what will be happening, guys? Then what will be water? So then what will be happening? That will be a case of homogeneous or heterogeneous? What do you say? That will be a case of homogeneous or heterogeneous? Can it be a heterogeneous case or not? Please tell me that. Yes? Any doubt till here? No? Okay, very good. Now see here. What we are going to see here, the examples of heterogeneous equilibrium are, see here, ferrous oxide, right? Ferrous oxide, FeO is there, and which is in what? Which state? Solid state. And see here, with gaseous carbon monoxide, that is what? CO, carbon monoxide, right? Carbon monoxide, giving what? FeS and CO2. They both are in different phases, right? If they both are in different phases, so it will be a what? Heterogeneous equilibrium. Heterogeneous equilibrium. Is it okay? Any problem? No? No. See another example here. We are having what? Water. See guys, water, if you are evaporating water, right? Like steam is there. If steam is there, then what will be there? Reaction of steam with red hot carbon produces hydrogen gas and carbon monoxide. So this is what? Water is there, but in gaseous state. That is what? Evaporating water is there, right? And carbon is there, right? In their solid state. So what we are going to get here? H2, that is gas, and CO, that is also gas. So one is gas, another is solid, and another we are getting what? That is gas and gas only. So this will be what? Heterogeneous. Is it okay? Now tell me about the CO2. CO2 is gas, carbon is sulfur, carbon is carbon is in solid state, and again we are getting what? That is what? CO, that is in gaseous state. So we are getting what? These all are the examples of what? Heterogeneous equilibrium. Is there any problem till here? Guys, please tell me. No? No. Again. What are the applications of this equilibrium constants, right? That we are going to see. What are the applications of this equilibrium constant? See, first is what? Expression of equilibrium constant is applicable only when concentration of the reactant and products have attained constant value at equilibrium. What is the meaning of this line? See here, AA, that I have written BB, and giving what? This is, if I am writing this, it is meaning, the meaning of this is what? They have attained the equilibrium condition. If Kc value is finding, if we are finding the value of Kc, its meaning is what? That the equilibrium condition has been attained, right? So if we want to find the Kc, so what will be the Kc then? Concentration of C to the power small c and concentration of D to the power small d upon concentration of capital A to the power small a and concentration of B to the power small b. So expression for equilibrium constant is applicable only when concentrations of the reactant and products have attained constant value at equilibrium. So their value will be what? Constant only. Is it okay, guys? Second one is what? The value of equilibrium constant is independent of initial concentration of the reactant and product. See guys, whatever be the, let's suppose here 5 mole is there, right? 5 mole is there. And finally, after the product, see, after the reaction has been in equilibrium condition, so the both side will be what? The concentration of this side and the concentration of this side will be in equal condition only. Is it okay? Equilibrium means what? They will be in equal, either left or either right. Either the reactant side or the product side, they will have the same concentration. Is it okay? So the value of equilibrium constant is independent of initial concentration of the reactant and products. Is it okay? Now see the next point. Equilibrium constant is temperature dependent, having one unique value for particular reactions represented by a balanced equation at given temperature, right? So it is dependent on what temperature. Fourth point is what? The equilibrium constant for the reverse reaction is equal to the inverse of equilibrium constant for the forward reaction. See, I will be explaining these things in equations, right? What is saying here? Equilibrium constant for the reverse reaction. Let's suppose the reaction is what? Backward reaction is there, right? So for forward reaction, if Kc is something, right? So what will be the value for the reverse reaction? What is saying here? The equilibrium constant for the reverse reaction is equal to the inverse of equilibrium constant for the forward reaction. Let's suppose whatever be the value that you have got. Let's suppose you have got A for the forward reaction. For the forward reaction, you have got Kc, the value of Kc is what? A. For backward reaction, if you want to find the value of Kc, then it will be what? 1 upon A only. That is saying here. Is it okay? So the value of Kp, so the value of Kc for forward and backward reaction will be what? Because we are finding what? We are having formula what? Kc equals to what? Concentration of A, that is product, upon concentration of B, upon concentration of C, upon, sorry, it will be what? Product upon, we have taken A, B, C, D in that direction, that's why I am taking here like that only. So concentration of C to the power C, concentration of D to the power D, this is what? Forward reaction, yes. And backward reaction will be what? Concentration of B to the power B into concentration of A to the power A. This is what? Backward reaction. So if let's suppose the value of this is what? A. So the value of this will be what? Kc, for the value of Kc, it will be what? 1 upon A only. Now, the equilibrium constant K for reaction is related to the equilibrium constant of the corresponding reaction, whose equation is obtained by multiplying or dividing equation of the original reactions by a smaller integer. So when the equations will be coming, then I will be discussing more about this, right? Now, one more thing is that predicting the extent of reaction, how far the reactions will be going, that we will be seeing here. See here, the numerical value of equilibrium constant for a reactions indicate the extent of reactions. So whatever be the numerical value, that is whatever be the stoichiometry, that will be depend that how far the reactions will be going forward. But it is important to note that an equilibrium constant does not give any information about the rate at which the equilibrium is reached. See how equilibrium constant Kc will not tell you about how fast or how slow the reaction is, because this is a part of what? Kinetics. This is not a part of Kc. So rate will be not determined by this. Is it okay? It will only tell you that about the equilibrium condition, whether equilibrium has been attained or not. Is it okay? So that we are going to see what? Equilibrium constant does not give any information about the rate which the equilibrium is reached. The magnitude of Kc or Kp is directly proportional in the numerator of equilibrium constant expression and inversely proportional to the concentration of the reactant. That, see guys, Kc or Kp, they both are same thing. Kp is used for what? Pressure. Kp is used for what? Pressure. And Kc is used for what? Concentration. So what is Kc? See here, what is saying? The product of what? Product of product. See here. For forward reaction, product of product. That is what? C up into C into D into D. What is saying here? See here. The magnitude of Kc or Kp is directly proportional to the numerator of equilibrium. Numerator of equilibrium will be what? See guys, forward part, and forward part is what? Concentration of C to the power C and concentration of D to the power D. Yes, and it is also saying that the numerator of the equilibrium constant expression and inversely proportional to the concentrations of the reactant. So concentration of reactant is what? See here, concentration of reactant is what? We have seen in this case, concentration of reactant is what? This is the reactant part, yes. So concentration of reactant will be what? this will be the concentration of reactant, that is what? Concentration of A and concentration of B to the power B. Is it okay? Any problem till here, guys? So that is saying here the magnitude of Kc or Kp is directly proportional to the numerator of the equilibrium constant and inversely proportional to the concentration of the reactant, right? So now you can see here, this implies that a high value of K is suggestive of a high concentration of product and vice versa. High product means what? If product is more, it means what? The value of this and this will be more. Product is related to what? Concentration of C and concentration of D. So if the value of C, concentration C and the value of concentration D, then the product will be what? More. And if the value of concentration B and concentration A is less, it means what? We are having lesser reactant. Is it okay? Is there any problem till here? Okay, fine. Now guys, there are a few things that we have to keep in our mind that we are going to see, and after that we'll be seeing about that. See here, there are a few important points. These are only you have to keep in your mind. I hope these things is clear to you guys. Kp, Kc, concentration Kc, yes. How to find that? Now, see here. If value of K, see here, if value of K is greater than 10 degree, that is temperature, product predominates over reactants. If is very large, the reactant proceeds nearly to completion. Is it okay? So if that will be completion, if that is about the completion, then what will be happening? See here, the reactions of H2 with O2 at 500 Kelvin has a large equilibrium constant, that is 2.4 into 10 to the power 47. 2.4 into 10 to the power 47. Now see here, and reaction with what? H2 plus Br2, giving what? 2HBr at 300 Kelvin temperature. The temperature is same. H2 is there. In the case of Cl2 and Br2, there is a difference of what? There is a difference of Cl2 and Br2 only. So we are getting what? At the same temperature, we are getting what? Kc equals to 5.4 into 10 to the power 18. So you can see here what is the difference. So there may be a difference of what? See here, you can see here H2Br2, same temperature. We are getting what? Different products. Now, one more thing is what? If the value of Kc is what? Lesser than 10 to the power minus 3. Kc is what? 10 to the power minus 3. Reactants predominates over products, and if Kc is very small, the reactant proceeds rarely. That is what? If Kc is very small, the reaction proceeds really. It means what? The reaction will be not going to happen. Is it okay, guys? So if the reactant is so small, then the product will be not going to happen. Then you will be not getting the product part. That is what? Lesser than 10 to the power minus 3. Now, the decomposition of H2O into H2 and O2 at 500 Kelvin has very small equilibrium constant, that is Kc 4.8 into 10 to the power minus 48. Now, see here. Now we are going to see about the predicting the direction of the reactions. How to find the direction of the reaction? This is very important part. See here, guys. How to find the direction of equilibrium? How we can find the direction? See, guys. Direction is directly proportional to what? See, we have to see what? Kc and Qc. If you are pro with Kc and Qc, you will be able to find the direction. See, there are three conditions. Kc is equals to Qc, Kc is greater than Qc, and Qc is greater than Kc. And we are having what? Three directions as well. Forward direction, backward direction, and if the reactions will not proceed, then no direction. Is it okay? Please have a note of these things, guys, first, then I will be explaining the next. Now, see here, guys. Have you noted all these things? Now I'm going to tell you what. See, let's suppose we are having equation this time. See, this is one reaction, that is AA, BB, CC, DD, that I used to write, right? But let's suppose another reaction is there, that is what? Alpha A plus beta B. This is beta B, and then what? It is giving what? Gamma C, and what? Delta D. This is the reaction, right? So if we have to find Kc, and I will be also showing you what will be the Qc. Kc is equals to what? Who will be telling me what will be the value of Kc here? Guys, please tell me what will be the value of Kc. Can anyone tell me about Kc? Zero degree? Who is saying 0 degree? Yes. So what is the value of this Kc, guys? Can we write concentration of this C to the power gamma into concentration of D to the power delta upon concentration of A to the power alpha into concentration of B to the power beta? Can we write for this or not? Yes, guys. Is it okay? So this will be at equilibrium. This is for at equilibrium, right? No. If I have to write what QC, if I have to write what QC, see, for QC also we will be writing what? Concentration of C to the power gamma into concentration of D to the power delta upon concentration of B to the power beta into concentration of A to the power alpha, right? But the condition is what? ABCD, the concentration of A, B, concentration of C, concentration of D are not at equilibrium. This can be any condition. Right? Okay. Fine, guys. Any problem till here? Clear till here? now see here guys. See, case 1 I am going to write here what that is. Case 1 is what? If QC is greater than KC, then what will happen? Reaction will shift towards forward or reaction will shift towards backward? Who will be telling me? See, first of all I am writing that reaction will shift towards forward, right? Reaction will shift towards where? Backward. If QC is greater than that, so backward direction will be what? Backward direction. So first condition is clear. Write these things, then I will be explaining you. How this will be happening, I will be explaining you guys. Any problem till here? No? Okay. Second case is what? If QC is lesser than KC, then what will happen? See, reaction will shift towards forward direction. Is it okay? Very good. And if QC is equals to KC, then what will be happening here? Reaction at equilibrium condition. Is it okay? Now, how to find this? Who will be telling me? How we can say that this will be happening? Can anyone tell me? See guys, if QC is greater, QC means what? See here. If product is greater, QC is greater means what? Product is greater. See here. We are having this container, right? And this container, right? Now, here is what? KC. Let's suppose here is what? Reactant. Here is what? Product. If we are having QC is greater, right? QC is greater, then it is what we are having? We are having what? We are having what? If QC is greater, then it means what? We are having this part is more. This part we are having more, right? This part we are filled. And see, this part is more and this part is lesser one. If QC is greater, it means what? This part is in greater, product is in greater part, and reactant is in lesser amount. So it will have to do what? Backward reaction to attain the what? Equilibrium condition, because this is at this is at what? QC is, we are finding the QC at any point of time, right? So we will have to what? Shift our reaction towards backward to get the equilibrium condition, right? So if QC is greater, that's why I have written here, if what? If QC is greater, see here, QC is greater, reaction shift towards backward direction. Is it okay? Are you able to understand now? If QC is, if QC is smaller, it means what? Reactant is smaller. If QC is smaller, it means what? Reactant is in greater side. Reactant is in greater side. See here. This is your reactant. And now this is your product. Right? So QC is greater than KC. Then what will happen? So if it is having more reactants, right? So it will have to do more reactions towards the forward side to attend what? Same condition, same amount of reactant will be here also. Then only will be having the equilibrium condition, yes or no? So to attain the equilibrium condition, the reaction will shift towards where? Forward direction. Is it okay? So if QC is greater than KC, then there will be what? Forward direction will be there. Forward direction will be there. Is it okay, guys? Any problem till here? Now, I hope if these two conditions are satisfied, then QC is equals to KC. And can you tell me that if reactant side and the product side, if you are having the same amount of concentration, will there be need of forward or backward direction then? No, the reaction will not be either shifting forward or backward direction. So it will be in what condition? It will be in equilibrium condition. Is it okay? Any problem till here? Guys, please have a note of all these things. Then we will be going ahead. There is one question, guys. Have you written everyone? Question is what? Please have a note of this question. And then you will be able to understand more. The question is what? What is the Atasha? What is the problem? Is there any doubt? Do this question. I hope you will be able to understand that. Question is what? Find QC. Question is what? Find QC and predict and predict the direction of direction of equilibrium. The direction of equilibrium. Reaction I am going to write you guys. See here, reaction is what? 2SO2. Reaction is what? 2SO2 giving plus O2. See here, 2SO2 plus O2, right? 2SO3, 2SO3, right? And Kc is what? Kc is equals to what? 278 mole inverse. So try to find the direction as well as the concentration. One thing is more, just a minute. 0.01 mole of each of the SO2, O2 and SO3 are mixed in a 1 liter flask. Try to find the answer of this question. Atacha, a good answer. So guys, how you have find? Apart from Atacha, anyone else who has find the answer of this question? See, this is a very easy question. See how to find the answer of this question. We are having the formula for finding QC, right? QC is what? I have given you the formula for QC is what? Concentration of what? Product. And what is the concentration of product here? That is what? SO3. So can we directly write the SO3? SO3. And power will be what? 2. Because sufficient is what? 2. And upon what will be there? SO2. SO2 is what? SO2. Concentration of SO2 to the power what? 2. And concentration of O2. O2 to the power what? It will be 1 only, right? So can we write like this? Each one is having what? 0.001 mole, right? So can we write like this? 0.001 mole to the power what? Square. Is it okay? Upon what? Upon what? This is what? SO2. So SO2 is also having what? That is 0.001 square into O2. That is also 0.001. But there is no square, right? Here there is a square. So this square and this square will be cancelled out. Yes or no, guys? What do you say? Is it okay with everyone? Any problem? So we are having what? What we are going to see here. In denominator we are having what? We are left with what? 0.001. If in denominator it is remained with 0.001, it means what? If we will be going to find, then what will be the answer? Can you please tell me? If let's suppose if I have to bring this in forward or backward, what will be the direction? Can anyone tell me? Can anyone tell me what will be the direction for this? Backward direction. How we have got the backward direction? Atachaya, can you please tell me how you have got the direction backward? Although you have find I have that is completely good.
Sir,
Atachaya, yes.
we have that 1 by 0.001.
Yes, 1 by 0.001. Very good.
Which gives 1000.
This gives 1000, right? So
Yes.
if you will be yes, it will be equals to 1000. Yes.
And that QC equals to 1000. So
So this is Kc equals 2000. Yes, or Qc equals 2000.
QC, sir.
Qc equals 2000. Yes.
1000.
Yes. And
And
Kc.
KC they given the 278.
Yes. See here. What is the Kc here?
278.
Yeah. Kc equals to 278. So Qc is greater than Kc, right?
Yes.
So if you will be going to find, then Qc will be equals to what? Qc equals to 1000 and Kc equals to 278. So Qc is greater than Kc, right? So the reaction will move towards where? Backward. I have taken example as well. If Qc will be greater, then reactions will be moving towards where? In the backward direction. Is it okay with everyone? See, we have just informed this thing, guys. Please see here first. Vishnupriya, please see here. I have told you earlier also. If Qc is greater than Kc, the reaction will be shifting towards where? Backward direction. Although here I have written like wrong, but the reaction will be shifting towards backward direction. If Qc is greater than, then the reaction will be shifting to. Here might be I have written some from somewhere else, but Qc is greater, then the reaction will be shifting towards where? In the backward direction.
So do they always provide the KC value, sir?
Yes. What you are saying?
Do they always provide in question? Do they always provide the
No,
KC
no,
value?
no, 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 no. Every time it will not be possible to provide you the Kc value. Sometime Qc value will be given to you. Sometime Kc value will be given to you. So it depends upon the question and question. I will be giving you one more question. Have a break of 5 minutes, 5 to 7 minutes, and after that I will be giving you another question. Then we will be seeing whether you are able to do or not. Right?
Sure, sir.
Okay, fine. Are you there, everyone? Yes. Okay. The second question goes to you. Question is what? NOBR is there, right? Giving what? NO, this is gas, plus half here, right? And this time Kp has been given to you. Kp is equals to what? 0.15 atm, right? This has been given to you. And the question is what? If NO bar, NOBR, right? NOBR, NO and BR2 are mixed, right? Having partial pressure 0.5 atm, 0.5 atm, comma 0.4 atm and 2 atm respectively, right? Respectively. Predict the direction of equilibrium. Do guys. Anyone who has found the answer of this question?
Oh,
Yes,
sir,
yes,
is it backwards?
just a minute. We'll have to solve this first. So what is the value that you have got for QC? That is QP.
Concentrations on the last paper.
Yes. Anyone else who has found the answer for this question? Although Vishnupriya, your answer is correct, right? But let's check with other people that what they are doing. Atachya, what is
So
your answer?
1.13.
What is your answer?
1.13, sir.
Yes, 1.13 is the right answer. Anyone else who has found the answer for this question? Guys, what do you think? What will be the right answer for this question? See here. We have to find the QP, right? Same way as we have found QC, there will be what? QP will be there. So what will be the answer for this? P. P and O, right? You'll be writing what? P and O. Into what? See here. BR is there, right? So we'll be writing what? BR, right? PBR. And their coefficient is what? What is their coefficient? That is 1 upon 2. So we'll be writing what? To the power 1 upon 2. Is that okay? One upon 2 will be there. And what will be the then reactant? Reactant is what? NOBR. So P NOBR. This will be there. Everything is clear here. Anyone any problem? See here. The coefficient is what? Nothing here. 1 will be there. And with NO, the coefficient is what? 1 here. And with this BR, 1 upon 2. So I have multiplied it what? I have given the power raised to 1 upon 2 only, right? Is it clear, everyone? Now, the value has been given to you. What are the values? What are the value, guys? See here. See here. What are the value that I have given you? See. If NO and BR2 are mixed with having a partial pressure that is 0.5 atm. So what are the pressures that we are having? That is what? 0.5, right? And 0.4 atm and 2 atm respectively predict the direction of the equilibrium. So what I will be going to write here first for P and O, partial pressure of NO. What I will be going to write here? Can anyone tell me? For NO it is what? 0.4. So I should write 0.4 here, right? For BR, what I will be going to write for this BR? So 2 and 2 to the power what? 1 upon 2, guys. Upon it will be what? 0.5. Please solve this and then tell me the right answer. What is the right answer for this? What do you think, guys? Can you please tell me? What will be the right answer for this question? Who has solved this question? See, guys, can we just remove this point and can we write this 4 upon 5 into 2 to the power 1 upon 2? It will be what? 2 to the power 1 upon 2, it will be what? It will be a root 2 only. And the value for root 2 is what? Value for root 2, I hope you all are coming from the mathematics background. What will be that? 0.1, 1.414. So can we multiply it by 1.414? Yes. So multiply this, you will be getting what? Value of root 2 is what, guys? 1.414. And value of root 3, who will be telling me? Value for root 3 is what? 1.73, I hope. 1.7314, like that, right? So what will be the value for this? If you will be going to multiply this, then what will be the right answer then? 1.732. Yes, value for root 3 will be there, 1.732. Now here, if you will be going to multiply, then what you will be going to get here? 4 into 1.414 upon 5. Will that be greater than 1? Guys, please multiply and tell me. It is your part only. This is not my part. So again, what you are getting? QP is greater or what? QP is greater than KP. See, this will be what? If you will be going to multiply and divide, then you will be going to get what? 1.13. Although Vishnu Priya has given the answer earlier only, right? So what will be the answer? 1.13, and this is what? QP is greater than KP. So what? The reaction will be moving towards what? Backward. Yes, Vishnu Priya, can you please explain this? Backward direction. Yeah, last time Atachaya has explained the question. Now Vishnu Priya, it's your turn. Please explain this. How you have got the answer?
So first I have substituted the values for 1.5 ATM for 0.4 ATM in the equation QC is equal to QC equation.
Yes, yes.
By substituting the value of 2 into power of 1 half is 2.
Yes.
Multiplying root 2 into 0.4 divided by 0.5, I get an answer 1.414 into 0.4 divided by 0.5.
Yes.
5.656 divided by 5 gives the answer for 1.131.
So that is good. But how you have find that QP is greater than KP?
Since in the question they have mentioned KP value as 0.15, it's clearly visible.
Yes.
It is
So
clearly
now you
greater
can
than
see
the
KP is
QC.
what? 0.15, and it is what? 1.13, guys. So it is what?
Since the QC is greater than KP, is backward direction.
Yes. Got everyone? Is there any problem? See, guys, as we are writing for KP, if you are confused about the KP, then what we will be writing the KP? KP will be equals to what? Similar way in KC, what we are writing? Concentration of the product side upon concentration of what? Reactant side. Concentration of product side upon concentration of product side. Sorry, concentration of product upon concentration of reactant. In the similar way, if we have to find KP, we will be writing what? Partial pressure of what? Product side upon partial pressure of the reactant side only. There will be P term will be used. There we were using the concentration term, and this will be used for gases, and there we were using for what? Anything. Is it okay now? Now come to the point. So we have seen so many things here. So now come to the point. This we have seen, right? Now, see guys, if QC is greater than KC, the reaction will proceed towards, I hope everybody is now comfortable with this. If QC is greater than KC, the reaction will proceed towards the direction of the reactant, reverse direction or what? Is it okay? Reverse direction, that is in the direction of reactant, backward direction, reactant side. Yes? Is it true or not? Please tell me that. Who will be telling me? If QC is greater than KC, then the direction of the equilibrium will be shifting towards backward or forward. Who will be telling me, guys? Please write in the chat section. Backward or forward? Backward or forward? Backward. But here there is wrong has been given. See here. What is that? QC is greater than KC. It has been given what? Direction of the product is forward. See here. This one is wrong. Okay. See, actually it will be like this only. If Kc is greater than Qc. And here it will be what? Qc is equals to Kc. The reaction mixture is already at equilibrium. Is it okay? Any problem to anyone? No problem? No. Just a minute. See here guys, what is there? If H and that is what plus I is there. It is not 1, it is what I is there. Giving what? 2Hi, right? H2 is there. Suppose we have molar concentration H2 that is 0.1. Here H2 will be there, right? And I2 that is 0.2, right? 0.20 N. So Hi equals to 0.40, right? And T subscript is used for the concentration symbol, right? Means that concentration were measured at the arbitrary T, not necessarily at equilibrium, right? So what will be happening here? So if we have to find QC, I have told you how to find the QC and how to find the KC. I have told you this. Is there any problem? See guys, if you have to find the QC, so it will be what? Concentration of 2Hi, concentration of Hi, right? To raise to the power what? 2 upon concentration of this H and concentration of this I. Yes or no? I see here. In the similar way, they have been also written here. QC equals to what? Concentration of Hi raised to the power 2 upon concentration of H2 upon I2. So we can find the value of this, right? So try from your side here. Actually, H2 and I2 will be there. So find the value of QC. What will the value of QC? Value of, I hope this will be very easy question for you. H2 has been given 0.10. I2 have been given to you 0.20, and the value for Hi has been given to you 0.40. Then find the value of what? You have to just find the value of what? Just find the value for what? What has been given here? QP. Sorry, QC. So try to find the value of this, then we will be moving ahead. This is a very easy question, guys, because you have found like a tough question in the previous. Anyone who has got the answer for this question? Right answer is what, guys? Please, can anyone please tell me? See here. We have to just put the formula and get the answer, right? It has been given to you what? That is what? HI, that is what? 40. And H2 and I2, that is what? 0.10 and 0.20. That will be in denominators only. And this will be only in numerator, right? So what will be there? 0.40 upon 0.40 upon 0.10 into 0.020, right? So what will be the right answer for this? What is the right answer for this, guys? This is 0.40 here. If you will be going to multiply this, what you will be going to get here? Anyone else who has found the answer for this question? Kaniska has found, and Vishnu Priya. Yes, Vishnu Priya. So what you have got here? What is the value? That is 8 only. Kaniska, 8 only. Yes. So what will be this,
8.
guys? 2 to the 4. Yes. And then
And
finally, yes. Yes, then.
question?
Yes, see here. 2 point is here and 2 point is also here. So 40 and 20 will be there, right? And here is there what? 0.10. Can we multiply it by 100 in the numerator? And then you will be going to divide it by what? 10. So what you will be going to get here? So what is the right answer for this? 8, right? Now, if 8 is there, so it is in forward direction or will be it in backward direction? What do you say? Will it be in forward direction or it will be in backward direction? How you have found that it will be in forward or backward? Yes, guys. What do you say? See, actually we have seen that. See here, what we have seen here. Actually, what has been given here? H2 value is given, I2 value has given, and Kc value has been given, right? We have just tried to find what? Yes, very good. Kc is greater than Qc. Yes. Yes, Kc is greater than Qc. Kc is greater than Qc. Yes. Okay, fine. I hope now you are able to understand these things, right? I think there is no problem in this type of question. Anusika, are you able to do this question? Yes. Asrita Nahak, will there be any problem in this type of question? Asrita Nahak, Kaniska. Ashwin Karthik, after so many time, after so long, I am going to see you here. Please turn on your camera. Bhuana, what about you? Okay, guys, see. So we have seen these things, QC, KC, about QC, KC, QC will be equal, then what will be happening, we have seen here, right? Is it okay? Any problem till here? And can we predict the direction by seeing the QC and KC value? See guys, what is happening here? If QC is greater, right? So it means what? It means what? The reactant is what? Where? If QC is greater, we have discussed these things. If QC is greater than KC, then what will be happening? Reaction will move towards left or right? So product is more, then then the reaction will move towards backward. Is it okay? Here is what? Kc is greater, right? Then reactant is what? Product. Then what we are going to see here? We have seen the directions and all, right? Now we have also find the calculating the equilibrium constant. We have seen the formula for this. We have also find the values of Kc and all, right? Now we are going to see about this delta G and all, right? There are few points about what? Equilibrium constant, K, reaction quotient Q, and Gibbs free energy or Gibbs energy G. See guys, in thermodynamics we have seen that if delta G is 0, if delta G is equal to 0, then will there be a reaction will proceed or not? Do you remember this? See, delta G is negative, then the reaction is spontaneous and proceeds in the forward direction. I have told you in this thermodynamics also. If delta G is what? 0 or less than 0, negative, it means what? If delta G is what? Less than 0, means negative. If delta G is negative, then what will be happening there? The reaction will be spontaneous, right? And the reaction will be in forward direction. Is it okay? Now, if delta G is positive, then the reaction is considered to be non-spontaneous. As reverse would be have a negative delta G, the forward reactions shall be converted into the reactants. And if delta G is what? Equals to 0, there is no, you cannot be find the reactions is shifting either in the backward or forward direction. Reactions has achieved equilibrium condition, that is what? If delta G equals to 0, if delta G is equals to 0, then it will be what? There is what? Equilibrium condition has been attained. So in case of minus delta G, spontaneous, plus delta G, non-spontaneous, and if it is equals to delta G equals to 0, then it will be what? Equilibrium condition has been attained. Is it okay? Any problem till here? No? Okay, fine. One thing that we will be going to see about what? The relation between what? Delta G and RT, and see about this we will be seeing the next class. There are a few things more that we will be going to see about this. Factors affecting the chemical equilibrium, right? What are the factors that will be affecting the chemical equilibrium, right? See guys, concentration changes, pressure changes, temperature change, and addition to all this, that is what? Catalyst. So what are the factors that will be affecting the chemical equilibrium? Concentration, pressure, temperature, and catalyst. Is it okay? So what are the conditions like that will be affecting the chemical equilibrium? That is what? Either it will be shifting towards forward direction, or either it will be shifting towards the backward direction. If there will be change in this concentration, or there will be change in pressure, if there will be change in temperature, or there will be change in addition of catalyst, right? Now, I'm going to show you something, guys. See here. I'm going to write one equation, and please try to tell me that. Have you got these things or not? See, first of all, stoichiometry of reaction. Stoichiometry means what? That is, you can say, that is concentration, right? Let's suppose we are having what? A, and it is converting to what? B. So if we have to find K1, K1 will be equals to what? Concentration of B upon concentration of A. Is it okay? And now, if the reaction is what? B is here and A is here, and we have to find what? K2. So can we write it? Concentration of A upon concentration of B. Can we write it like this? This is the first case. If I have to find the value of K2 and K1, then what I can write for this? Can we write K2 equals to 1 upon K1? Is it okay? Can we write like this or not? So please have a note of these things first. Now, second case, case 2. Case 2 is what? Now we are having again a reaction, that is what? A. We are getting what? B. So K1 equals to what? Concentration of B upon concentration of A. Okay. Any problem till here? Now we are adding what? See here. We are having what? This. In multiplication we are having what? A. And we are getting what? A, B. So for this, can we write K1 equals to B, concentration of B upon See guys, what are you writing for this? Can anyone tell me? Concentration of B to the power what? A upon concentration of A to the power A. Can we write like this? So what will be the relation then? Then what will be the relation between this K1 and K2? What will be the relation between K1 and K2? Can anyone tell me? Can it be K2 equals to K1 to the power A? Yes or no? Please tell me. Guys, please have a note of these things. So in case of multiplication, what we are going to see, if the coefficient, if the stoichiometric coefficient is multiplying, so we are getting what? K2 equals to K1 to the power A. Is it okay? Now, let's suppose we are having another type, that is what? We are having A, that is what? Giving B, right? Again, we will be writing what? K1 equals to concentration of B upon concentration of A. Yes. Now we are doing what? We are just concentration. See, stoichiometry is what? 1 upon A, and giving what? Coefficient what? That is 1 upon A, B. Then in this case, what you will be going to write? K will be equals to what? K2 will be equals to what? See guys, K2 will be equals to what? B, concentration of B to the power what? What you will be going to write? 1 upon A upon concentration of A to the power 1 upon A. Will you be going to write like this? So finally, what we will be going to get here? What can we say here? K2 equals to, can we write K2 equals to K1 to the power 1 upon A, 1 upon A. Yes, please have a note of this. Now, next thing is what? Next thing is what? Just a minute. Let's suppose now we are having what? A giving B and C giving D. So in this case, K1 will be equals to what? Concentration of B upon concentration of A, and K2 will be equals to what? Concentration of D upon concentration of A, right? Is it okay? Concentration of D upon concentration of C. Now, if we are adding A plus what? If we are adding A plus C and B plus D, C, can we add this? A plus C and B plus D. And in this case, what you will be going to get? A plus C and B plus D. Then what you will be going to get here, guys? This is K1, K2. So K3 will be equals to what? K3 will be equals to what? What do you think? First of all, forward concentration of B into concentration of D upon concentration of what here? See, D upon C will be there, guys. So here it will be what? Concentration of A into concentration of C. Yes or no? Is it okay, guys? Please tell me. So can we say here K3 equals to K1 into K2? Can we say here K3 equals to K1 into K2? What do you say? Is it okay? Any problem till here? No? So please have a note of these things.